Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on Fourier Transform. Fourier transform can be applied for both periodic and non-periodic signals. It can be represented in frequency domain. It provides an effective reversible transformation link between the frequency domain and the time domain representation of the signal. The spacing between the spectral components becomes infinitesimal and hence the frequency spectrum appears to be continuous. Periodic signal has a fixed period of T0. The continuous Fourier transform of the signal is given by x of omega is equal to integral over minus infinite to plus infinite x of t into e power minus j omega t into dt. Inverse Fourier transform x of t is equal to 1 by 2 pi integral over minus infinite to plus infinite x of omega into e power j omega t into d omega. X of t Fourier transform pair with x of omega, while we taking the x of omega Fourier transform pair with x of t. Convergence of Fourier transform, this is nothing but Dirichlet's condition, single value property, finite discontinuous, finite peaks, absolutely integrability. Single value property x of t must have only one value at any time constant within the interval t naught. Finite discontinuous x of t should have at most finite number of discontinuous in the interval t naught. Finite peaks, the signal x of t must have finite number of maxima and minima in the interval t naught. Absolute integrability, the signal x of t should be absolutely integrable. Integral over x of t into dt should be less than infinite. This is the representation of the signals. For Fourier transform is to convert from time domain representation into frequency domain representation, while we taking the Fourier analog signal with respect to time and amplitude as 1 kilohertz, that the converted frequency domain representation of the 1 kilohertz can be seen in the right hand side sequence. This is the one complete waveform can be divided by 2. It can be t by 2 with respect to time and amplitude. It has a 2 kilohertz that can converted into frequency domain representation. It has a 2 kilohertz with respect to frequency and amplitude. This is the signum function of t. Sine function of t is nothing but 1 for t should be greater than or equal to 0, minus 1 for t less than 0. Sin function of x is equal to sine pi x divided by pi x. The graphical representation seen on the right hand side sequence. While the Fourier transform is main to process of conversion of time domain into frequency domain, we are using analysis function and synthesis function. Time domain to frequency domain, that is s of f is equal to Fourier transform of x of t. While we applying the frequency domain, that with the help of synthesis that can be converted to time domain. S of t and s of f forms the Fourier transform pair. This is the Fourier time aperiodic signal with respect to minus 2 omega naught to plus 2 omega naught, minus 4 omega naught to plus 4 omega naught, the signal gets compressed. Again minus 8 omega naught to plus 8 omega naught, the signal again compressed with respect to omega. This is the periodic impulse train of the Fourier transform minus 2t to plus 2t. While we are applying the Fourier transform of the above time period function, we get the frequency response as x of j omega with respect to omega minus 4 by t2. 2t is nothing but is equal to minus 4 by pi t2 plus 4 pi by t. Now we can see the Fourier transform of decaying exponential function. That is nothing but e power minus at into u of t. Formula of the Fourier transform of x of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi f t into dt. While we are substituting e power at minus at into u of t is condition is nothing but 1 for t greater than or equal to 0, 0 for t less than 0. That's why we can take in the limits from 0 to infinite. We can take it as common e power minus of a plus j 2 pi f into t into dt. Now we can differentiate e power minus a into j 2 pi f into t divided by minus of a plus j 2 pi f integral over 0 to infinite. Upper limit minus lower limit, we can get x of f is equal to 1 divided by a plus j 2 pi f. Now we can see the Fourier transform of rising exponential function e power at into u of t. Again we can apply the same formula. Now we can differentiate and integrate with respect to minus infinite to 0. We can get x of f is equal to 1 divided by a minus j 2 pi f. Now we can see the Fourier transform of unit step function. X of f is equal to integral over minus infinite to plus infinite x of t into e power minus j 2 pi f t into dt. X of t is nothing but u of t is as the 1 for t greater than or equal to 0. While we taking the limits from 0 to infinite, e power minus j 2 pi f t divided by minus of j 2 pi f integral over 0 to infinite, we can get x of f is equal to 1 by j 2 pi f. While we taking the Fourier transform of unit impulse function, that is nothing but del of t is equal to 1 for t is equal to 0, 0 for t should be not equal to 0. Therefore, Fourier transform of unit impulse function is x of f is equal to 1. Now we can see the application areas of Fourier transform. It is used in telecommunications, GSM and cellular phones, in electronics or IT, most DSP based applications, entertainment, music, audio, multimedia, accelerator control, tune measurements for beam steer control, image processing, industry research, X-ray spectrometry, chemical analysis, PDE solution, radar design, medical applications such as MRI interpretation for sleep disorder, heart malfunction diagnosis. Fourier transform is used to analyze periodic and aperiodic signals, conversion of time domain to frequency domain. Define convergence of Fourier transform. Single value property, finite discontinuous, finite peaks, absolutely integrable. Fourier transform of unit step function is x of f is equal to 1 divided by j 2 pi f. Fourier transform of unit impulse function is x of f is equal to 1. The decaying exponential function of Fourier transform is given by x of f is equal to 1 divided by a plus j 2 pi f. List the applications of Fourier transform. It is used in telecommunications, electronics, entertainment, audio and video processing, medical imaging, etc. Thank you.